Continuing on with 4.3, we're in the second video, 4.3b, example 4, page 349. Now you've seen these kind of problems before. We're just solving them a little bit differently. So we've got a 20% solution of alcohol, and we have a 50% solution of alcohol. And we are mixing the two together, and we're trying to get 12 gallons of alcohol, and we want it to be 30%. So we're going to have to add a certain amount of each of these to get a number in between these. Okay, so the 50% is going to be diluted with the 20% in order for us to get a 30%, and we need 12 gallons of this stuff. So what are they asking? How much of this and how much of this are we going to have to mix in order to get 12 gallons of 30%? All right, so how much are we going to have to mix to get 12 gallons? Well, if we call this X and this Y, then in order to get 12 gallons, we'll have to take the amount we have of 20%, the amount we have of 50%, add those together, and we'll get 12. Okay, so there's my first equation, is the quantity. It's always going to be the quantity. Okay, the next one is going to be how much of this we're going to have to put together. Well, we're going to have to put 20% of X, and we're going to add 50% of Y, and that's going to give us a 30% solution and 12 gallons. So the difference between these two and this one is this one we know how many gallons we have. This one we don't know yet. We just know that 20% of this amount plus 50% of this amount is going to give me 30% of this amount, which is 12 gallons. So we're going to do the same thing we did before. Let's go ahead and move our decimals to, instead of leaving it here, let's change this to 3.6. Go ahead and multiply that out. 12 times 0.3. Now we're going to move the decimal 1 here, 1 here, and 1 here. So that gives me 2x plus 5y equals 36. So let's go ahead and erase that. We don't need it anymore. Okay. So now we have to figure out what we're going to do to solve this. Do we use substitution or do we use the addition method? I'm going to use substitution in this one. So we're going to take that one and we're going to write it as y equals 12 minus x. I just subtracted x from both sides, so that goes away. Now, in the second equation, wherever I see a y, I'm going to put a 12 minus x in its place. Okay, distribute. Move stuff up out of my way. This and this gives me negative 3x. Why does that always happen to me? Subtract 60, subtract 60. So negative 3x equals negative 24. And therefore x equals negative 24 over negative 3, which is a positive 8. Okay, so what did I find out? Where am I? My x solution, my 20% solution, I have to put 8 gallons of that in there. And my 50% solution, I'm going to take and add 4 gallons. And when I add those two, I'm going to have 12 gallons of a 30% solution. Okay, example 5. It takes 2 hours for a boat to travel 28 miles downstream. Okay, so I've got my little stream. I've got my boat. I'm not a real good boat drawer, but there we go. All right, so it takes this boat 2 hours to go 28 miles. So from here to here takes 28 or is 28 miles, and it takes 2 hours. All right, and that's with the current. So the current is going down like that. All right, the same boat can travel 18 miles. So let's draw the same boat. And he's going back upstream. And the stream is still going this way. But in that same amount of time, or no, not even that, he goes 18 miles upstream. But it takes him stinking 3 hours to do that. What is the speed of boat in still water? Because we have to know so we've got a current slowing us down or speeding us up, and we're curious what this is going to do in still water. So let's look and see what we've got here. Okay, I like the cool little tables that we can make here. I'm going to make it below. So we have up and we have down. Okay, distance upstream was 18 miles, and the distance downstream was 28 from our cool little picture above. Our time to go upstream, remember that was 3 hours, and our time to go downstream was 2 hours. Okay, so if you remember when we did the formula, D equals RT, distance equals rate, or the speed times time, we're going to use that same formula here. But what we don't know anything about the rate. We don't know anything about the speed of the boat going downstream or upstream. But we do know that if the boat were in calm water, no current, let's just say it went X. If it goes downstream, we get to go the speed of the boat in calm water plus the speed of the current. So I'm going to call 8 calm, and Y is the current, because the current is either going to speed you up or slow you down depending on what you're going to do. So when you're going downstream, you're going the speed in calm water plus the current is going to push you along. So that's how fast you're going to go downstream. When you're going upstream, you've got the speed in calm water, but you're going against the current. So the current is going to slow you down that much. So that's why we have a minus Y there. So if we were to use the formula, distance equals RT, which is over here. If we're going, let me get my blue pen here. If we're going downstream, or let's say if we're going upstream, that's the top one, D equals RT. 18 equals RT. Now T in this one is 3. So I suppose I should have a 3 on there instead of a T. All right, distance downstream is going to be 28 equals rate times time. Okay, so let's go ahead and do some finagling around a little bit. In fact, let's take both of these problems and move them over to the left. And we're going to switch some things around. I'm going to put the 3 x minus y on this side equals 18. And I'm going to do the same with the bottom one, just because I like to have the variables on the left and the numbers on the right. Now let's distribute this one. So we're going to get 3x minus 3y equals 18. And the bottom equation, we're going to get 2x plus 2y equals 28. Okay, pretty simple there. So this is our equation that we're solving x and y for. So we're going to use our systems of equations. Now the book does it one way. I'm not going to do it that way. You can look and see what they did. Actually, I guess if you just want me to show you, they factored out a 3 from each of these. So they factored out a 3, and then you're left with x minus y equals 6. And in this one, they factored out a 2, and they were left with x plus y equals 14. So this pair of equations is equal to this pair of equations. We just got rid of the common factors, the 3's and the 2's, and that left us this, which I guess it does make it a lot easier if you can follow that way of thinking. Not really too bad. We add these up. Those go away because those cancel. So x then equals 10. In calm water, the boat goes 10 miles an hour. What do they want to know? What is the speed of the boat in still water? And what is the speed of the current of the river? So there's the speed of the boat in the calm water. And the speed of the current would be if we took like this equation here. Speed of the boat, speed of the current equals 6. So y equals 4. But notice it's really -4 because this is the speed that's what's slowing us down. The current of 4 miles an hour is slowing us down. So we're going 10. It's slowing us down 4, and that means we're going 6 miles an hour upstream because we're pushing against the current. So even though this is -4, that's just meaning that the current is slowing us down. It's pushing us backwards 4. So 6 ends up being the current, or I'm sorry, 4 ends up being the current speed, whether you're going upstream or down. You're going to add 4 to the 10 to get 14 miles an hour, or subtract 4 from 10 to get the 6 miles an hour. But either way, the current is 4, and the boat in still water is 10.